We're going to go in much the same direction here as we did with the last problem. We're looking for groups of 3 here in this first example. And so we said, hey, there's a 27 in 135, and that represents 3 3s. So I can take 1 3 out. For every group of 3, I get to take one piece of it out. Not all 3 3s, but just one of them. So anyway, that's very similar. Here, let's see what we have. We can make the denominator a perfect 5th power, and so therefore that will get rid of the excess. So that's kind of an interesting trick. We say, oh, you don't have a group of 5? Well, here, let us add some more. You realize if I have the same thing on the top and the bottom, I haven't changed the value of the fraction, but I made the bottom have a group of 5 so I could get rid of the radical on the bottom. So that's interesting. Okay, so it's an option anyway. It's an option. It's kind of like when we get rid of a radical on the bottom. That's kind of like what we're doing. We did that with conjugates, but anyway, this is a little different. So write the expression in simplest form. Well, 256. So I grab my calculator, or I think to myself, this is kind of tedious, I suppose, but I kind of split it up into 2s as much as I can remember. I was going to say that was 56. That's not so. That's 64. And I'm not doing it with my calculator, but you could. You could just keep dividing by 2. And so we're looking for groups of 5. So I need one more 5, or 6, groups of 6. Sorry, I need 2 more. Okay. And so here we go. Here are my 6, right? 1, 2, 3, 4, 5, 6. And I just, I just sort of go about it on my calculator if I desire. And so this is the same thing as 2 to the 6th. That's what I was trying to write, 6. And then how much was left over? Well, there's this 4 that's still stuck in there. And this is to the 6th power. So what that means is I can bring 1, 2 out. For every 6 inside, I can bring 1 out. And what's left inside? Oh, it's not the square root. It's the 6th root. Way different. Of 4. Okay? And that 4 is stuck inside. So it's 2 times the 6th root of 4. Okay, that's the simplest form. And then let's see here. So we didn't have the fraction thing. That was interesting. Well, I'm sure we'll have an example where we do that, like we did up here. But not yet. So let's take a look at this. We have 5 times 2 is 10. And then I can combine the things under the 4th root. And let me just say 8 to the 2nd power times 8 to the 1st power. That doesn't work out as nicely as it could, but let's think about this. I just happen to know 8 times 8 is 64, and I really don't want to multiply them together. I want to go the other way. I'm looking for groups of 4. So let's rewrite this as 10 and the 4th root of, this is 2 to the 3rd. 8 is 2 to the 3rd to the 2nd power times 2 to the 3rd again. So what I'm going to have here is 10, 4th root of, 2 times 3 is 6, and then I'm going to add it to the 3, so I have 2 to the 9th. All right. Now I'm looking for groups of 4. There's 2 groups of 4 in 9, right? That would be 8. And so that means 2 of the 2's come out. Should I write that out in detail? Let's write that out in detail. I have 2 to the 4th times 2 to the 4th times 2. That's the same thing as 2 to the 9th. So each one of those 2's that are to the 4th are coming out. So now I have 40. 4th power. How many 2's got trapped inside? Just the 1. Okay? So there we go. That's what we get. We're looking for groups of 4. We found 2 groups of 4. So the 2 2's came out. The 2 2's came out as a 4. 4 times 10 is 40. 2 got trapped inside, and make sure it's still inside. Yeah. All right, there we go.